Hi, this video is on combining and solving. I want to talk for a second about the conditions that we need to be able to do backtracking. So this backtracking method, I hope you can see it's nice for some things, but it has limits, and like a lot of methods in math, we kind of need to think about when we're allowed to use it. So if we look at all these different equations listed here, I've got 3f minus 3 equals 6. I've got 2 times the quantity g minus 4 equals 8. And on down the line, all of these equations here in my list have one thing in common, and that's that they've just got, all my variables are collected into one spot. I don't have kind of x's or n's or p's or g's or whatever it is clutter all about in my equation. I've just got a kind of single letter, because basically I can't do forward, backward. There's nothing to reverse from if I don't have a single letter. Second kind of limitation on forward, backward too is that it doesn't work if I have something that's nonlinear. So if I have squares or square roots or cubes or different powers, there are some limits with forward, backward. I can't really do that there because there's some issues with, that I have two answers and I can't just reverse everything. Okay, so for the condition for forward, backward to repeat is that I just have a single variable there. Okay, so that brings us to the topic of this video, which is combining and solving. So the truth is I am going to have situations where those variables are going to be cluttered about, and I got to be able to deal with that. So just a kind of quick reminder on combining. If I have like a variety of these simple cases here, I can just, 1d plus 1d, that's just 2d's, right? This is an expression. There's not an equal sign. I'm just simplifying it. So this is obviously going to give me 2n. And I'm looking here. I've got 1 p's. Remember, just counting like that 1 in front of that p. 1 p's plus 2 p's, that's 3 p's. Minus 2, and that's as simple as I can get that. So that's combining like terms. Okay, now, we can have certainly more complicated situations, for sure, like this one, for example. I think my big advice in this, and I'm just going to recopy, my big advice in this is to kind of have some system to kind of match what goes with what. So in this case, this isn't too complicated because I only have h's. Sometimes I have more than one variable. I could have x squareds in there. But in this case, I just have h's. Okay. What do I need to remember? I need to remember that the sign needs to go with these, so that negative is going to go with my h. So what do I have there? I've got 2 h's, okay, and if you want to be really careful, 2 h's plus 4 h's, plus negative 1 h's, if you want to look at it that way. That minus goes with it. So I got 5 h's. Alright, so I got 5 h's, and then I've got a 6 and a minus 1, or a 6 and a negative 1 for this piece. So 6 plus negative 1, I'm just combining my constants, so I've got 5. So what's my simplification there? It's just 5 h's plus 5. Alright, so what do we do then if we have our, where the teacher is asking me to do forward, backward, but I've got my n's or h's or t's or whatever lying about. I just need to combine first, then I can do it. So if I look at this one, for example, I've got 4 t's minus 8 t's. Alright, well, let's take a look at that. So, 4 t's minus 8 t's, I don't even have any constants, so that's easy to do. I've got a negative 4t then, equals negative 16. Well, does that meet my criteria now? Yeah, because I got only one, I got all my variables collected in one spot. So now I can go forward, backward. If I plugged in, I'd have a times negative 4. And if I reversed it, then I'd have a divide negative 4. So negative 16 divide negative 4, I'm going to get t equals positive 4. So positive 4 is the answer. So that might be kind of overkill. You might be kind of, how come I can't write that out traditionally from that point? And to be honest with you, you can. I just want to show you this way of thinking about this. All right. If I ask you to, that's what you'll have to do. So if you look at something like, well, let's go ahead here. If I'm flipping ahead, this is page 44 in the course pack. We're going to look at number 7 and number 8. I think those are good to contrast. So this is page 44, number 7 and number 8. So I've got, let me see here, 2 times u minus 2, okay, plus u equals 10. All right, so I'm going to look at this and I'm going to say, hey, can I just reverse this thing right now? Could I do forward backward from this? The answer is no. Why not? Because I've got more than one u lying about. So now I got to distribute. So I've got 2u minus 4 plus u equals 10. Okay? So I got 2 u's plus 1 u's. That's going to give me 3 u's minus 4 is 10. And then I can solve from there. So if I'm going to do forward backward, I've got forward is times 3 minus 4, backward is plus 4, divide 3. And then I've got 10 plus 4 is 14. 14 divided by 3 is just 14 over 3. I can't simplify that. So u is 14 over 3. And if you're getting comfortable with this, with your forward backward and how that works, you could practice kind of just writing the backward steps from this and then the answer. You can even just go from here to the answer. The idea is that this backtracking is supposed to be a tool to help you. It's not just a kind of evil thing to make you do. It's supposed to be something that helps you, you go faster, get more correct answers. Okay. All right, let's look at number 8 also, which is right next to it. So that was number 7. Like I said, this is page 44 in the course pack. Okay, so number 8 is, let me see here. So number 8 is this negative 4 plus 3 n plus 1 equals 17. Okay. So what am I going to do in this? Well, in this case, I got to be thinking to myself, well, can I reverse this? Yes, I can, because I only have one n. So even though, because sometimes students get in the mode where it's all one thing or all the other. Like, since now sometimes I distribute and distribute all the time. Well, let me just say you can go faster and avoid a lot of errors if you're looking for opportunities to do your forward backward when you can. Alright, so I'm looking at this. I'm just going to do it now. Forward backward. I'm going to start with my n. I'm going to say plus 1. Then times 3. Then this is going to be the same thing as a takeaway 4. If you want to put plus a negative 4, more power to you, you're going to end up with the same thing. I'm going to just say minus 4. Okay? Alright, now I'm going to go up, takeaway 4. Alright, I'm going to go up. Then I'm going to reverse them. So I've got plus 4, divide 3, take away 1. And then I just add these up. So I've got 17 plus 4 is 21. Divided by 3 is 7. Take away 1 is 6. So I have n equals 6 is my answer. And I'm done. So what's the point of this? I just want to stress, if I got u's lying all over the place, like in number 7, I want to do the distributing and the combining and find my u and my forward backward. If I have just a single n, it is often easier to just kind of do the reversing right off and just get my n as 6. Okay? All right.